Welcome to qnawire.
Now in this question, we're looking back at question 52 where we talked about a roller coaster with a vertical loop section that has a radius of 12 meters. Now it is designed that the speed, right, as it comes in is 22 meters per second, but now due to friction, right, the speed it slows down, right, to 15 meters per second. Now we're still going to assume that within the circular loop itself, it is still frictionless, but right now it enters the loop at a speed of 15 meters per second. Now we want to find whether is it more dangerous or less dangerous than the situation previously. Now, in order for the passengers to remain on the roller coaster, it means that when the roller coaster reaches the height, right, the maximum height over here where the passengers are overturned, the amount of acceleration required to keep them in circular motion, which is v square over r, must be greater or equal to g, right? The acceleration due to gravity. So if it's less than g, it means that g, the acceleration due to gravity, will be more than enough to keep them in circular motion, and the circular motion actually breaks down, right? Because you're exerting force that is greater than that of the circular motion, than the force required to keep in circular motion. So v squared r must always be greater than g. Now what is our v? Well, that depends on how much kinetic energy is lost, right? As it goes from 15 meters per second to up to this position. Right? So the lost in kinetic energy is just the gain in the gravitational potential energy, which is mg times 2r. So the overall final kinetic energy is at half mv squared must be equals to half m times 15, the original kinetic energy, minus the lost, which is mg2r. So the velocity at the top over here, v, right? So v squared, let me just find v squared first. This will be equals to 15 square minus 4g times r. So we know that r is given as 12. 12 times 9.1 times 4. 15 square minus that answer. And we see that this is equals to a negative value. Right, so in fact, what happens is that the roller coaster is not possible for it to actually reach the top over here, because the maximum height that it can go would just be half m times 15 square equals to mgh. The highest, right, maximum height it can go would just be half of 15 square divided by g, which is 11.5 meters. Right, therefore it cannot even reach the midway points over here. It will only stop at this particular position, right, at 11.5 meters above the ground. So in fact, it becomes less dangerous for the passengers because there's no chance of the coaster being lifted off the track, right, or losing contact with the track, since it is always below the midway point of the circular track.